Um, Hello everybody. In this video we're going to look at an example of nonlinear programming. It's a Markowitz portfolio model. Right. So we looked at an example of the index fund. That's another video there. You should definitely go watch it. In this video we're going to be talking about the Markowitz portfolio model. When looking at optimization, portfolio optimization, basically, there are always two things that are that you have to keep track of: risk and return. Now, in many of the linear programming formulations, return was our objective. In the previous, in the index fund formulation, the risk wasn't the objective. The objective was to be as close to the return of the index fund as possible. But a Markowitz portfolio model is a mean variance portfolio model, which is a convenient way in which a investor can actively trade risk and return, right? So you have this trade-off between risk and return, and it's a simple way of doing that. So we'll take an example of a very similar example that we had before. We'll demonstrate the Markowitz portfolio model by extending the index fund model that you have. Right. Now, the portfolio variance is the average of the sum of the squares of the deviations from the mean value under each scenario. So what does this mean? So you look at the average value for each of the scenarios. So that was the return 1, return 2, return 3 that we calculated in the index fund. And then you find the average of those 5 returns, and then you calculate the variance based off of the average of the different returns that you have. So you had R1, R2, R3, R4, R5. Those were the returns for each of the 5 years. Those were the average returns for each of the 5 years. Then you find the average of all of those averages. You're going to call it R bar. So there are two ways in which you can do the Markowitz model. So we calculate the value of R bar, which was the average value of all of that. And using the value of R1 through R5 and R bar, we're going to calculate the variance of that value. So you calculate the variance, then you minimize the variance. So variance is one of the ways in which you measure risk of a portfolio. There are other ways of measuring risks of portfolio. In fact, all of these hedge funds and all of these investment companies, their secret sauce is mainly about the way they differentiate themselves from their competitors is how they value risk. Everybody has their own complex formula for how they value risk, and they found that it works well, or it's giving them enough returns that they either meet or beat the market at a consistent level. So that's the idea there. So there are two ways to formulate the Markowitz model. One is to minimize the variance with constraints on the expected return, or the other way is to do the opposite. The other is to maximize the expected return, which is what we did. But the one thing that we don't have is we didn't put a constraint on the risk. Now, in some of these models, we did have risk constraints where we had risk values of risk for each of the different investment options that you had, and using that calculate something, but that's still a static way of doing it. Now, number 1 is a better way of doing it than number 2, because by option 1 or by doing number 1, you have the objective be a nonlinear function while all your constraints are linear constraints. But in type 2, if you look at the second way of formulating the Markowitz model, your objective will be linear. Most of your constraints will be linear, but you'll have one nonlinear constraint. And it's always difficult to deal with nonlinear constraints. It's much easier to deal with nonlinear objectives than nonlinear constraints. And you know this. I mean, we saw that in the previous videos that I posted with nonlinear programming, right? So we will do the type 1, and we will assume that we want to create a portfolio so that the client receives at least 10% return. That's the minimum return that the client wants based upon the data that you have. Okay, so let's formulate this problem. So let's formulate this problem and set it up. Now the constraints are going to be very similar to this, right? So the step 1, the decision variables. So we have the same decision variables that we had before. It's the proportion of the portfolio invested in the stock, foreign stock, intermediate bond, large cap growth, large cap value, small cap growth, and small cap value. Of course, we have the return. So we calculate return R1, R2, R3, R4, R5, just the same way that we did before. So if you remember correctly. And then we're going to calculate something called R bar. So R bar is the average return, right? So PS is the probability that each of these values occur. So the way you think about the Markowitz model is you have these data from 5 different years, and then you assign a probability for each of these 5 different years. So if you look at the returns that we get, right? So if you look at returns in year 1, returns in year 1 are high, returns in year 3 are low, returns in year 5 are the worst. So you say that I have these 5 different years where different things happen. I have a medium return year, I have a really good year, a really bad year, some medium years. How likely is it that you're going to have a year that looks like this? How likely is it that you're going to have a year that looks like this or this or this or that? So you assign probabilities for each of these years. And this obviously comes from experience. Or you can just make a guess. And if you have no data, if you have absolutely no data about which, how you think it's going to happen, what you can do is you can assume that the probabilities are all equal. So there are 5 different scenarios. So you can assume that each of them, 5 different years. So you can assume that each of them has a probability of 1 over 5, right? 20%, 20%, 20%. Or we can assume that they have different probabilities, in which case you can multiply the probability with the return, and add them up to get the expected return, right? After that, we calculate the variance. So the variance is the difference between each of the returns. So each of the R1, R2, R3, R4, R5, and R bar. So you take the difference of those values, square the differences, and multiply it with the corresponding probabilities. Now for this model, we are going to assume that the probabilities are all equal. So we're going to take 1/5, 1/5, 1/5 each time, but it doesn't always have to be 1/5. It can be different probabilities, right? And we'll see that. So I'll set this model up as a 1/5, 1/5, 1/5, and then we'll see what happens if the probabilities are different, right? Okay. Right. So the final model looks like this. So the objective is to minimize the variance subject to the constraint. So these constraints are the same. So they have the 5 returns that you have, then the variables all have to add up to 1. These were the same returns, the same data that you had in the index fund value. But apart from that, you are also going to calculate R bar. That R bar is the average value of all of these 5 returns. And then you want R bar to be at least 10%. You want a minimum of 10% return. And you're going to use the value of R bar in the constraint, in the objective. Right? So let's set this up in Excel and solve it and see how it goes. Now obviously it didn't work out for us last time. Maybe it'll work out this time. Let's see. Just this portion I'm going to copy to I'm just going to copy to a different file just in case. For some reason it was not working out last time. So. Okay, so let's so apart from this, we also have R bar. I'm just going to say R bar right here. And then the left hand side and the right hand side values. Okay. We have a R bar constraint to add. So the R bar constraint is that, oh, we didn't write the constraint. So let's write the constraint. So all of these have to add up to zeros. So I'm just gonna this has to add up to 1, right? So all the returns have to add up to 1. Then R bar is equal to, so if you look at the constraint here, so it says R1 plus R1 1 over 5 times R1 plus 1 over 5 times R2 plus 1 over 5 times R3 minus R bar is equal to 0. So again, I don't want variables on the right hand side. So it's going to be 1 over 5 1 over 5, 1 over 5, 1 over 5, 1 over 5, right? 1/5, 1/5, 1/5, 1/5 minus R bar equal to 0. That's how I'm going to set mine up. And then, of course, we have the final constraint that you want a minimum 10% return. Just to say that R bar has to be greater than or equal to 10%. There you go. R bar has to be greater than or equal to 10%. That's our final constraint. Now the objective function, so I'm going to set up the objective function straight up here. I don't want to write it in multiple steps because maybe that's what was causing the problem last time. So the objective function is 1 over 5, so 20% times R1 minus R bar squared plus, so let's put all of this in parentheses, another 20% times R2 minus R bar squared plus another % times R3 minus R bar squared. This is the variance plus R4 minus R bar squared plus 20% times R5 minus R bar squared. Right? Oh, R bar is also a decision variable, so let me mark that. All right. We can have them all cleared up, right? So that's my decision variable. So these are constraints. So let's write the sum product for the constraints. So the sum product formula. All of this, these have to be absolute references. Okay. Next up is the solver. Mess that up. Okay. I mean, it doesn't matter. It could have been there. We'll end up with the same answer, but I'd rather do it. That's my objective function in N4. And then first are the equal to constraints. Right. I forgot my. Too much of a hurry today. Minimize. Don't forget that. All of these are equal to constraints. And then one greater than or equal to constraint. Right? Click on solve. And again, we might end up with no solution. I'll just show you the solution for the other one. But I have a feeling we'll end up with a solution this time. Okay, there you go. Solver found a solution. So R bar is exactly 10%. We got exact 10% return, and these are my return values. So let me make them percentages. Oops, and that also. right? So you're saying invest 13.2% in foreign stock, 50.3% in intermediate bond, 6% in large cap growth, 0% in large cap value, nothing in small cap growth, and 30% in small cap value. This will give us an average return of 10%, minimum of 10%, and it will minimize the variance. Now, if you look at the other Excel file that I had where I solved the exact same problem, you'll notice that my return here is similar. So 13.22, 50.1. So we got the same answer as we got before. But sometimes you might end up with different answers. I mean, that's okay too. That's okay too. So there's a percentage also. So all of these are percentages. Let me just write them out as percentages. Couple decimal places. Right. So first year you expect 19.65%, 10% in second year, 5.61, 9.55, 4.59% in the 5 years. Excuse me. Of course, R bar is 10%. And then the variance is 0.28%. That's how much variance you have, and you're minimizing the variance. That's the lowest variance you can have. You cannot have a variance of lower than 0.28%. And you'll get that by investing it this way. Right? And that is the Markowitz model. Right. So very common model. Now, the only other thing that could be potentially different is instead of probabilities being all 5 years being equally likely, you can look at the returns and say that, okay, fine. It's the beginning of the year and you have an idea of what you have a guess as to what the market is going to look like, and you might say, well, not all probabilities are 1/5, 1/5, 1/5. Let's say that for this year, you are somehow not, you don't think well of this year. You think that this year the returns are not going to be great. So if you look at the returns, year 5 is when you get the least returns. If you look at the numbers here, notice that year 5 is when you get the least returns, year 3 is the next least return. So maybe you say that fine, instead there's a 30% probability of this happening, there is a 30% probability of this happening, and there's only it makes it 60. Let's say there's a 20% probability of this happening, and there's only a 10% probability of each of these, right? Right? So let's say if that's the case, now what? So if the probabilities are different, the other thing to remember is that you have 10%, 10%, 30, 20, and 30. You have to make those changes in the objective also. So the objective also has the same probability values. So 10, 10, 30, 20, 30. Right? Now if I go to the solver and solve this problem, you might end up with a similar answer, but you might also end up with a very different answer. We'll see. You'll notice that it's taking a while, it's taking some time now. Now you got a very different answer, right? If the probabilities were different, if you think that it's not going to be doing great, then small cap value and large cap growth, small cap value and international bond, this is where you're going to put majority of your stocks, and 25% large cap growth, nothing in foreign stocks, large cap value or small cap growth, right? Based upon these probability values. Now, if these probabilities change again, then again, change the probabilities here, change the probabilities here. The only thing to remember is that the probabilities all have to add up to 1. They all have to add up to 1. That's obviously true. Otherwise, it will not work. Okay. All right. So that's the Markowitz model.